Welcome class, and welcome back to my Applied Science College channel. Today we are going to proceed with the chemistry, the redox titration, and we are just going to go through some questions here for the volumetric analysis in as far as redox titration is concerned. First of all, before we tackle anything, we are supposed to know what is the meaning of the redox titration. Redox titration is a lab technique that it's a lab technique to find unknown concentration by reacting it with the unknown solution, which is also called a titrant in oxidation reaction, or it is oxidation reduction reaction, or the redox reaction, whereby the electrons are transferred using the indicators or electrodes to spot the end point, or when the reaction is complete. So in this case, let me just take you through this question paper, the titration practical 11 poly, because we are through with the titration practical 10, so we are proceeding with titration practical 11. So in this case, I'm just going to take you through the questions so that you can be able to find out how these questions are supposed to be answered, so that when I'll come next time, I'll be able now to give you the exact figures, and we shall be able to give you the right answers on how these questions are supposed to be answered, and also how they are supposed to be calculated. So without wasting time, I'm just going to take you through the questions. Then we start. You are provided with solution G, which is acidified potassium permanganate containing 3.16 grams per liter of a solution. Solution H, which is prepared by dissolving 4.17 grams of solid iron 2 sulfate, that is an iron 2 sulfate salt, an iron salt, in distilled water, and the solution is made to 250 cubic centimeters of a solution. So you are required to determine the value of N in the formula FeSO4.NH2O. Procedure, and it reads: place the solution G in a burette, put 25 cubic centimeters or 25 mils of solution H into a clean conical flask. Titrate H with the solution G until a pink color just appears. Record your results in the table 1 below. Repeat the procedure 2 more times to complete the table below. So this is the table that you're supposed to complete, and you can see it, how it is supposed to be drawn. So in column 1 is the one that is labeled 1, 2, 3. Those ones are column, but the rows are final burette reading, initial burette reading, and the volume of solution G used. All of them are in cubic centimeters. So remember, when you are filling that table, it is supposed to be filled following the principles of titration, and they are supposed to be either in 1 decimal point throughout the table or 2 decimal points throughout the table. If you, for example, if you write 18, you are supposed to write 18.0. If you have found the end point is maybe 19, you are supposed just to write 19.0, not just a mere 19 without a decimal point. At least 1 decimal point. So we have been asked to calculate the average volume of solution G used. We have been asked to calculate the average volume of solution G used. Then we have also been asked to calculate the concentration of solution G in moles per liter, whereby we have been given K, which is potassium, is equals to 39, Mn is equals to 55, and then oxygen is equals to 16. So we have been also asked to calculate the number of moles of solution G used. So we shall do that when we shall come back again. But I'm just giving you some questions so that you can go also and try on your own, and then you will be able to come up with your answers, and then we shall be able to compare. So that is what we call learning. So we shall be able to see where we have gone wrong, and we shall be able to rectify. Then, Roman 3, we have been told to calculate the concentration of solution H in grams per dm cubed. We have been told to calculate the concentration of solution H in grams per dm cubed. And then we have been told, see, given that the ionic equation for the reaction is that equation as you can see it, ion 2 in aqueous solution plus manganese MnO4 negative, which is also in aqueous, and then also it has some hydrogen ion in aqueous, and then on the product side, as you can see, we have that Mn in 2 positive, and then we have also Fe3, and then we also have some water being produced as a liquid on the product side. So in this case, you can see in that equation between the two that ion acts as a reducing agent, which is being oxidized to ion 3, and then while the potassium permanganate acts as the oxidizing agent, which is being reduced to manganese 2 in an acidic medium, as you can see, because you can see them the way they are. We have the product side and we have the reactant side and the product side. So we have been asked to determine the number of moles of solution H in 25 cubic centimeters of solution. We have been asked to determine the number of moles of solution H in that 25 cubic centimeters of a solution. So we shall be able to calculate them. Okay. So we have been also asked to determine the number of moles of solution H in 100 cubic centimeters of solution. We have been asked to determine the number of moles of solution H in 100 cubic centimeters of a solution. And then we have been also asked to determine the relative formula mass of iron salt with N water of crystallization of iron 2 sulfate with N water of crystallization. And then we have been also required to determine the value of N in the formula of that iron 2 sulfate N water of crystallization. So given that the relative atomic mass of iron is 56, sulfur is 32, oxygen is 16, and hydrogen is 1. So I hope that one has come to the end of the questions in as far as redox titration is concerned. When we shall meet again, we shall be able now to discuss these questions, and we shall be able to see how these questions are supposed to be answered. But students who are following me online, please just make sure that you try to calculate these questions on your own so that we can be able to compare our answers. That is the learning process, and that's how we shall be able to know where we have made mistakes, and we shall be able to rectify them so that we can be able to proceed with the redox titrations using maybe different kinds of solutions. Otherwise, remember to subscribe, also to like, and also just to give some comments down the video, and we shall be able to communicate. Otherwise, thank you in advance and bye bye. Thank you.